Howdy, folks. Got a few questions to start with. So the first question, and I'll just do these in the order they are here, is about, in question 40a, how do you find cosine of 0? So really the question is, what's cosine of 0? And when you go to find cosine of 0, you go to your unit circle and you look up a 0-degree angle. So a 0-degree angle with the positive x-axis would put you here. So that's labeled 0, 2 pi on your unit circle. And so if you actually look at the coordinates, this point is 1, 0. And so the cosine of 0 is 1 because the cosine comes from the x-coordinate. Okay, so next up, 41a gives you this graph of some piece of a trig function and asks you to find this tangent line. And so the graph here is f of x is sine of x plus cosine of x. Okay. And the question is, how do I find the y-coordinate of this point? Because I did not actually tell you any coordinates of this point. Okay. So the fact that they're asking about the y-coordinates suggests to me that they know that because this is on the y-axis, the x-coordinate is definitely 0. But as this point is on the graph of this function, this point has to be an input-output pair. So remember, always a point on a graph is an input and an output. Okay. So what's the output that matches the input 0? That's f of 0. And f of 0 is sine of 0 plus cosine of 0, which is 1. So that is 1. Uh, 42c, you need to do something with a cosecant of 2x. And so the question is, what on earth do you do with a cosecant of 2x? And the answer is, you use the only two identities that you can. So what is cosecant? Cosecant is 1 over sine. And now I have this double angle formula for sine. So I can rewrite this as 1 over 2 sine of x cosine of x. Okay, so next up, someone asks about 40c. So in 40c, our function is h of theta is equal to theta times sine of theta times cosine of theta. And the thing I want to point out here is that this is a triple product. So I'm almost positive the reason why people are asking about this is because it's a triple product instead of a double product. So how do we handle that? Well, basically I'm going to do this still as a product rule for a function product of two things. So the first thing is theta times sine of theta. And my second thing here is going to be just cosine of theta. So again, this h of theta, it's a product of theta times sine of theta. That's the first part. And cosine of theta, that's the second part. So I know how to take the derivative of theta times sine of theta. And to do that, what I did was to just use the product rule, right? So basically, in order to handle two products, the moral of the story is you have to do the product rule twice. And so then h prime of theta is a prime b plus ab prime. I'll go ahead and leave simplifying this and plugging in pi over 4 to u. But this is the sort of novel part of this question, or the part that we don't see nearly as often. Okay. (41C). We're asked about the equation of the tangent line to h of x equals tangent of x plus cotangent of x at, and then there's this point drawn in the graph. So we've got this little thing here, this little thing here. So there's an asymptote. There's an asymptote. And we want the tangent line here. Now, it's pretty clear from the picture that at this point the tangent line is horizontal. So in fact, in order to figure out exactly what this is, I actually have to work slightly backwards. And I'm working backwards from the fact that I know I'm looking for a spot where the derivative is 0. So I'm going to write down the derivative of h of x, which is secant squared of x minus cosecant squared of x. And I'm going to solve for when this is 0. Okay, so this is 1 over cosine squared of x minus 1 over sine squared of x. So this is sine squared of x minus cosine squared of x divided by sine squared of x times cosine squared of x. Now, I want to know when this is 0. So remember that when I want to know when a fraction is 0, I look at the numerator. So I can solve this. And so ultimately, I am looking for the places where sine of x is equal to plus or minus cosine of x. So those are all the root 2 over 2 places where either sine and cosine are both root 2 over 2, both minus root 2 over 2, or one is plus root 2 over 2 and one is minus root 2 over 2. That is, the solutions here are x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 in 0 to 2 pi. But which one is this point? Well, if I count starting at the x-axis, sorry, I should say if I count starting at the y-axis, that's what I'm pointing to, the first one would be there, so this is the second one. So this point must be x equals 3 pi over 4, comma, and then I need to find the y value there. Okay, again, this is the point that corresponds to pi over 4. So this is the point that corresponds to 3 pi over 4. It's the second one. Okay. The y-coordinate here is going to require us to calculate h of 3 pi over 4. Which is going to be the tangent of 3 pi over 4 plus the cotangent of 3 pi over 4. And if you calculate both of these, in fact, are minus 1, so this is in total minus 2. So in this question, actually, the hardest part was finding this point. Because now that I know what this point is, now the rest of the problem sort of falls apart. Because what's the horizontal line that has 3 pi over 4 comma minus 2 on it? Well, it's y equals minus 2. So that ends up being the answer. I'll say just a word about 42D. So 42D asks you about the derivative of sine cubed. And so the thing you want to do here to figure this out is to say, okay, I don't know the derivative of sine cubed. But we've talked about how to find the derivative of sine of x and how to find the derivative of sine squared of x. Okay. And so what you want to do is realize sine cubed of x is sine of x times sine squared of x. So you can use the product rule, with that being your a and that being your b, and then putting that together with the way we took the derivative of sine squared, which remember was to realize that sine squared is just sine of x times sine of x, that will let you take this derivative. And it looks to me like that's about all of the questions that I got. Feel free to put questions in the chat if there's anyone hanging around who wants to ask about anything. But I'll be here for another almost 2 hours, so let me know.